Hey everyone, I hope you're doing well today. Happy Sunday. Best of luck on the exam if you haven't taken it already. My name is Troy, and I'll be talking to you a little bit about nucleotides. So, what makes up a nucleotide? There are three components that make up a nucleotide. There's a phosphate group, there's a 5-carbon sugar, specifically a pentose, and you've got a nitrogenous base. So I just abbreviated it P for phosphate, P for pentose, and B for base. So PPB. That's just an easy way for me to remember what makes up a nucleotide. So I made a handy dandy little organic chemistry model, and just to show you a little bit better. So right here we've got this 5-carbon, 5-carbon ring, this pentose sugar. Attached, coming off this 5th carbon, is this phosphate group here in yellow, which is attached to an oxygen, and then it also attaches further up to another oxygen, and then another nucleotide up there. And that's why it's called a phosphodiester bond. You've got a phosphate, phospho, di, 2, ester, oxygen. So 2 oxygens connected to a phosphate group and making a bond between nucleotides. And last but not least, we've got this little purple guy, which is the nitrogenous base coming off. And this can be in DNA, it can be adenine, thymine, guanine, or cytosine. And in RNA, it is adenine, uracil, guanine, or cytosine. Yeah, hope that helps. I like little 3D representations. So more specific on the nitrogenous bases. We've got 2 categories of nitrogenous bases. We've got purines and we've got pyrimidines. And purines, you've got adenine and guanine. Adenine and guanine are both 2 rings, A and G. I like to remember that by thinking of A and G, ag, like the Aggies, CSU Aggies back in the day. And then I remember the pyrimidines by CU, cytosine, uracil, CU, buffs, I don't know. Purines we like better, we're pure. And then pyrimidines, you got CU. So yeah, pyrimidines, you got cytosine and uracil, which is in RNA only, and thymine, which is in DNA only. And those, of course, are only single rings. Going back to this page, what differentiates a ribose from a deoxyribose? So a ribose is essentially just a 5-carbon pentose with 4 alcohol groups coming off of it. And a deoxyribose, it's in the name, D without oxygen. So it's without oxygen on the 2nd carbon. So instead of this being an alcohol, it's just a hydrogen coming off. And deoxyribose forms into deoxyribonucleotides, or DNA. And this is unique because it's an anti-parallel, double-stranded, rather than a single strand as in RNA. And I've just shown a simple ATG sequence in DNA here. So you've got an adenine base, which is stacked on top of a thymine, which is stacked on top of a guanine. And these, of course, have its complementary bases, A to T, G to C. A to T has 2 hydrogen bonds, G to C has 3 hydrogen bonds. And of course, it's running 5 to 3 in an anti-parallel fashion. And as I talked about earlier, phosphodiester bonds are between the 5-carbon and the 3-carbon, and it's via a dehydration reaction. So yeah, I just signified an ATG sequence here in DNA, ATG, and in RNA, instead of ATG, it would be AUG, so AUG, adenine, uracil, guanine. Same phosphodiester bonds, it's just single-stranded instead of double-stranded. So yeah, I hope that makes sense. Let me know in the comments below if you've got any questions. Thanks for listening. Good luck on the exam.